Hi friends, welcome to my channel. In today's class, we will discuss how to draw the perspective projection or perspective view of the given solid. Here perspective view means it is a three-dimensional view. Whatever object we are seeing from any one particular direction. So how the object is looking in the 3D view. Okay, in three-dimensional view. That view is called perspective view. And or we can say if you are taking the camera, we are taking the image of any object. That image is also called perspective view. Let us do this perspective view by taking this given data. Here one solid has given, square pyramid has given. Square pyramid means this is a square pyramid. It has one base, it is the square. All four sides has equal length and it has apex. Okay, this has some height. Okay, this base and this apex are connected with the help of slant edges. Okay, so this is a square pyramid. We need to do the perspective view of this square pyramid. The position of the square pyramid has given in this question. Let us take initially. Here also I did the square pyramid roughly. Okay, a square pyramid of base side 40 mm. Each side of the square is 4 cm. Okay, this is the base. Just now I told. So each side is 4 cm. And axis 60 mm. That is height of the pyramid is 6 centimeters. Okay, height is 6 centimeters. Height means so from center of this square to apex, this distance is called height of the pyramid. Okay, so it is the height like this. So this is the imaginary line. It is called axis. Axis means two big lines with a dot. This is a rough diagram I did here for marking the dimensions. Okay, no need to do in the sheet. We just do roughly. Okay, this height of the pyramid is 60 mm and each side is 4 cm. And then rest on GP. This square pyramid is resting on the GP. GP means ground plane. Okay, remember that name, GP. Here I am doing one rough diagram. Let us take one horizontal plane. So this is GP, ground plane. Okay, so here we can call these lines are ground lines, GL. GL. Okay, we are keeping the pyramid so on this horizontal plane or ground plane. Okay, this entire plane is called GP. Now we are keeping this pyramid roughly I am doing here like this. So this is the square pyramid we are keeping on the horizontal plane, that is ground plane. Okay, now here after that with an edge of the base parallel to 15 mm behind the PP. PP means here picture plane. Initially I will do the picture plane. After that I will take this base edge is parallel to this PP. Okay, PP means picture plane. Remember it. Just roughly I am taking like this picture plane. So I am writing this is PP. It is a transparent plane. Okay, if you are taking here. Okay, this is a picture plane. So it is a transparent plane. Okay, now what it has given, an edge of the base parallel to and 15 mm behind the PP. One of the edge of the base parallel to PP. This like this. One of the edge is parallel to PP. Okay, this is PP. This is it parallel to PP? Yes, it is parallel to PP. So two edges are parallel to PP. Here we can't take any one of the edges because it is symmetrical. Okay, so let us assume we are keeping this edge is parallel to PP. So the position will be coming like this. Okay, and one more condition has given and 15 mm behind the PP. So behind the PP means this is PP. So behind it, okay, back side of it, 15 mm distance. So this whatever edge is parallel to this edge is 15 mm behind this 15 mm. So this is a transparent one. We can see this solid or we can see this square pyramid. One of the edges parallel to PP and 15 mm behind the PP. Okay, got it. Next is the station point is 90 mm above the GP. Station point means observer eye here is 9 cm above the ground plane. So observer is standing on the ground plane. This is the ground plane. So I am taking here one observer. Okay, roughly like this. So he is standing on the ground plane. Okay, so his eye we are taking, this is a station point. Okay, he is watching this solid. So his station point means this one. Okay, eyes. This station point is how much distance from GP? 90 mm above the GP. Station point is okay. So his eyes are 90 cm from the ground plane like this. Roughly I am marking. So outside I am marking this dimension 90 mm from ground plane. He is standing on the ground plane. Station point is this is S. Okay, so it is 9 cm. The station point is 90 mm above GP and 75 mm in front of PP. Okay, from the picture plane he is standing 7.5 centimeter in front of the plane. So this is a PP plane. So in front of means, so this gap from this picture plane to observer eye is 75 mm. Just roughly I am marking here. Okay. So his station point is 90 mm above GP, 75 mm from PP. So one side of this picture plane, he is standing, okay, in front of it. Behind it, this solid is there. Correct? And next is, and lies in CP. CP means center plane. This center plane is which is 40 mm towards the right of the axis of the pyramid. Here one center plane is there. Always remember, center plane is passing through the observer eye like this. It is like this. This is the center plane, like door. Okay. This center plane is, I am writing here CP. This center plane is perpendicular to this horizontal plane. Okay, that is 90 degrees. Okay, this angle is 90 and also perpendicular to this picture plane. Okay. So if you are taking this angle, okay, like door it is. Okay, this is perpendicular to center plane, this PP as well as this horizontal plane. Okay, center plane is there. Where is the center plane? CP, which is 40 mm towards the right of the axis of the pyramid. Where is the axis of the pyramid? So this is the axis of the pyramid. From axis of the pyramid, right side, okay, right of the axis of the pyramid, 40 mm distance. Okay, so this is the axis. So right side means this one. So this is 40 mm. So this center plane is situated, okay, from the center of this square pyramid or from axis to this center plane, 40 mm distance. Okay, this is the given data. So observer is watching this pyramid, okay, through this PP because it is transparent one. He can see this pyramid. Whatever image is coming, it is a perspective projection. We need to do it. Okay, so here next, draw its perspective projection. So here three planes are coming: ground plane, okay, picture plane, and then center plane. Okay, the position of this pyramid has given in this question. For doing this, initially we have to do the top view. Top view means if you are seeing this pyramid, we can see this square from the top. Okay, if we are observing this, if you see from top, okay, if you see from top, we can see this square initially. Okay, so square is coming exactly as it is like this. Okay, do that top view initially. Okay, for doing the top view, here we are seeing, we are getting the top view is square. For doing it, we have to do one more horizontal plane parallel to this. Okay, so it is called auxiliary horizontal plane or auxiliary ground plane. Just roughly I am doing here like this. Okay, this plane is called auxiliary ground plane. So here I will write GP, auxiliary ground plane. So this is also the transparent plane. If you see the object or the solid square pyramid from the top, we will get the top view. In top view, we can see this image square. If you see from top, we can see this square. Okay, if you are taking this pyramid, if you see from top, we can see this square. Okay, and then after square, we can see these edges also, all are meeting at the center. Okay, so here whatever top view we are taking, we will see initially this base. Okay, I will do this base on this auxiliary ground plane. Okay, this is also transparent plane, so we are seeing this top view, and also we can see these edges also. Okay, from top, so all are meeting at the center like this. This is the center of it. This is the top view we are getting for this square pyramid. Mark the names. This point I am giving capital A, B, C, D like that. So in the top view we will mark the small letters. Okay, A here, this point is B, and C, this is D, and take apex is capital O. Here apex is coming. Okay, this is the top view. So from the top view, instead of this square pyramid, we can see this gap also 15 mm. Okay, from picture plane PP. Okay, and this gap we can see in the top also. Whatever gap is there, same gap 15 mm. Okay, so this square here 15 mm from PP. This is the top view we are seeing. So this is the three-dimensional arrangement. Entire setting is. So we need to do in two-dimensional diagram because in the sheet we are doing in one plane. It is called two-dimensional. Okay, for taking this three-dimensional view in the 2D. Okay, so for that this auxiliary ground plane is here. Tilt this in this direction. Okay, it is initially horizontal tilt like that. Okay, so here if we are tilting like this, initially we can see this line here. We need to do this line. Which line it is? It is the picture plane line. Initially do the picture plane line. Okay, roughly I will do. After that, by using instruments, drawing instruments, we will do here. Here first initially we need to do this picture plane line like this. Okay, after that here after picture plane line here 15 mm, above 15 mm we can see this square. So above 15 mm we can see the square like this. Okay, names, give the names A, B, C, D, and then center like this. Okay, this gap is 15 mm. This plane is picture plane. Okay, this is a 2D top view. Okay, this top view. Now mark the observer also in the top view. If you are seeing from the top, okay, observer, where we can see the observer from picture plane, he is 75 mm distance. Okay, station point we are calling. So 75 mm distance from picture plane. So picture plane already we did. So 75 mm distance, the observer or station point will be coming. Okay, so here roughly I did the line after 75 mm. So here after 75 mm, so where he is, we can see this gap also from the top view. How much it is? 40 mm from center of this square. Okay, the station point is 40 mm distance. We can see from top view this distance also, this distance and this distance. Already we took this distance 75 from center of this. Okay, center means here roughly I am taking. So from center 40 mm distance. Let us assume the intersection point will come here. Okay, take that is the station point. Okay, yes I am giving. So this is the top view of the solid. This is the station point top view. Station point is coming. After that, in the perspective view or front view, okay, we are seeing the observer on the same projector line. Okay, this is the front view we are taking, H dash. Okay, we can call it as HV line also, horizontal line. We can call this line is HL line also, horizontal line. Horizontal line means, so through his eyes, one more horizontal plane we are taking like this. Okay, roughly I am doing like this HL. So from front, okay, from front we can see this HL line. Okay, do the HL line. Okay, after HL line, okay, how much distance is ground plane? 90 mm distance. So from HL to ground plane 90 mm. From HL to ground plane, just take here one more horizontal line. It is called ground plane or ground line. How much distance it is? 90 mm. So like that we have to do PP line, HL line and GL line. Initially we will do this diagram by using the drawing instruments. Here in this area we will get the perspective projection. Let us do this diagram. Okay, 2D diagram in this sheet. Okay, here initially take PP line of some length. Above PP do one square. So take one horizontal line here. So 15 centimeter from it. Mark one point. Here do one square which is passing through this point. Okay, initially I am using for doing parallel line roll scale. Do one line. Okay, square side, east side is how much? Square side 40 mm. Okay, so 4 centimeter. Let us take on it, take 4 centimeter. Make it dark. Remove the extra line and take 90 degrees. So in this direction 4 centimeter. Take 4 centimeter here and here also 4 centimeter. Do the parallel line, move the scale, take 4 centimeter line here. Here do the line parallel to this. Mark the points here. What are the points we have given? A, B, C, D. A, B, C, D. After that find the center. Join opposite ends. It is the center. These are the slant edges. Okay, this is the apex. For apex we are marking O. After that, after this diagram, so this is PP. Below PP 7.5, do one line. Okay, so this is PP profile picture. So below this PP, take 75. One line. Just do here one line for marking the distance. On it take 7.5 centimeter. So this is 7.5. Here do one line parallel to this. Just do one line. On it S is coming. Okay. So here from it take 40 mm distance from center of this to this station point. From this center it is 40 mm. So just do center line. Take this is the reference. Move up to the center. Just do one line. From center take 40 mm distance. Okay, this point. it is station point, yes. Okay, so after 40 we have marked yes. So take any gap between this line and this HL line, any gap we can take. On it we need to mark on the same line H dash. After this line, after some gap, I give small gap here. I do the thick line. This line name is called HL. We can take any length, HL it is. So on it, on the same projectile line, just do one projectile line here. For doing vertical line, take this line as a reference line, move the scale and do the line. This intersection point is H dash. Okay, front view of the, this is the front view of the station point. Okay, H dash I have marked. After that, from HL, take 9 cm, do the GL, ground line. Okay. For it, so take one vertical line. So from it, so at 9 cm distance, do one line here, which is parallel to this line. By using roll scale, take this is the reference line, move the scale, here do one horizontal line. Okay, this line is the GL line, ground line. Did the line here, GL line. So we got PP line, HL line, GL line. So after getting all the lines, here in the top view, we have to join all these points to the station point with the help of scale. So do with thin lines in the sheet. Here for getting the clear view, I am just doing the dark lines. We do all the diagram with the pencil only. Join to S, A point, similarly B also. Next from C to S. Next D to S. Like that, we have joined all the points to the S point. Okay, here whatever intersection points are there. Okay, so whatever A line will be there, I am taking that is A1. Okay, from B the intersection point to this line is B1. From C, this take this intersection point C1. From D, take the intersection point D1. Okay, so I am taking the intersection points with these inclined lines to this PP line. From A, I am taking A1. B, from B, I am taking B1, C, C1, D, D1, like that. Okay, after getting all these points, here join this point, okay, center point to S also, because it is one of the apex. Join this apex to S. Like this. So do the name of this intersection point also O1. Okay, after getting all these points, here whatever virginal points are there, A, B, C, D, from these points, just do the projectile line up to the last ground line. So here I did it with different colors for getting the clear view in the camera. Actually we had to do the entire diagram with pencil. Okay, after joining all these points, corner points and apex to the station point, this is the top view. Okay, now here we had to do the perspective view. For getting the perspective view, just do the projectile line from the main points. Okay, so here A and B both are coming on the same projectile line, and C and D are coming on the same projectile lines. Here these are the projectile lines, are the thin lines. Okay, do these lines up to GL. Like this. This point is, intersection point is, here it is coming AB. Both are coming here, A dash, B dash. Similarly, here also do the line. Do with pencil. Like this. Here this point is C and D, C dash, D dash. After getting all these points, at apex also do the projectile line up to here. Like this. So this is mark, this is center line. On it mark the height of this pyramid. What is the height of the pyramid? 6 centimeters given. Okay, so here mark the, here mark at 6 centimeters, mark the point. Okay, take this is O dash. Join all this A, B, C, D and apex points to H dash with the help of scale to H dash, getting inclined lines. So after getting these points, okay, here on the ground line, we have marked the apex also. This height is 6 centimeters we took. Okay, after that, if we join all these points, we will get the side view of the pyramid. Now our main aim is we need to do the perspective view. Initially we will do the perspective view, after that we will do the side view by joining this. Okay, now for doing perspective view, here wherever intersection points are there, okay, from A1, B1, C1, D1, like that, just do the projectile line from A1 up to A inclined line. From A inclined line here to A inclined line this side. Similarly from B to B inclined line to B inclined line. From C to C, D to D, like that. We will get the vertical projectile lines. Let us start from A. So this is the A point, okay, this one. So take any one of the line is the reference line, vertical line. So move the scale up to A1. Just do the projector line here. Okay, this is capital letter A. Similarly, from B also do the line, vertical line up to B inclined line. So this intersection point is capital B. Similarly, from C to C1. So intersection point, next intersection point of C to C inclined line. So this is the C inclined line. Just do the projector line. Okay, the intersection point is capital C. Similarly, D, from D to D. So this is the capital D. We got capital letter A, B, C, D, and mark apex also, from apex line, inclined line to apex point. Take this is the reference. We can take any vertical line. So from apex to apex line. This is apex. We did the line here. We will do the line here, apex to apex. This is capital O. Now join all capital letters A, B, C, D and A, and join all corners to the apex. We will get the perspective view. So join initially B to C, next C to D, next join C to D, next here this is the, if you are seeing this pyramid, this is the invisible point. Okay, whatever invisible edges will be there, those should be with dotted. Okay, do with dotted line. So here also it is dotted. So always remember, in 3D diagram, from each point three lines are passing, this line, and apex line. Okay, it should also dotted. Now other 3 points we have to join to the apex, continuous lines. Continuous lines means those lines we are able to see. So from C to apex and D to apex. So this is a 3D view, or we can call it as perspective projection. When the observer is seeing this pyramid, it is looking like this. Okay, this is a perspective view. Now for doing the side view, if you see from side, so if you join these points to this apex, we will get the side view in the same diagram, or we can do the side view here also. Okay, with another color I will do here. Now initially I have told, if you are joining these points to this apex, we will get the side view also in the same diagram. Okay, join A, B, C, D points and then apex. So this is the side view. If the observer is seeing, this side view is coming like this. Okay, so both diagrams we can do like this, or we can do side view here also. So take this procedure so that we can save space for other diagrams. So this is the side view, this is a perspective view, and this is the top view. Now mark the given dimensions. After getting complete 3 views, mark the given dimension. Square each side is 40. Keep one small square and 40. And then this is 15. And this distance is 75 given value. And this is 40 from center of this to station point. And then this is 90 up to GL. These are the given dimension. So this is the procedure of doing the perspective projection. We did all the 3 diagrams. So one more method we have. We can do this method, or in another method, we can do this side view separately here. Okay, both methods are correct. We can do in the combined diagram, and we can do this part only separately with this diagram. Let us see how to do the separate diagram, because this one and this one are coming together, and this diagram, green color diagram, should come here, side view. Let us see. Here I will explain how to get the side view of this diagram. Here we did this diagram. Okay, this is the top view, this is a perspective view, side view. Okay, already we did in the drawing sheet. Now here, how to do this side view separately. Here let us check. Okay, let us see how to do this side view separately. Here, after this diagram, after some gap, okay, just do one line, reference line. It is called x1, y1. Okay, are you getting this line? X1 and y1, vertical line. Okay, after some gap of this diagram, you can give any gap here. Okay, after doing this xy line, just from all the points do the projector lines up to this line. Okay, here also up to this line, from all the corners do the projector lines. Okay, after getting these intersection points, we have to take these points on this line, extend this PP line. We have to take all the points on this PP line. Okay, You can transfer all these points to this line, okay, by using curves. So how to do the curves? By using compass, this point as center, okay. Take this radius, whatever this radius is coming, take that radius, just do an arc here, okay, it will intersect at this point. Similarly, take this radius, shift this point here. Similarly, this point, shift here. Okay, we are shifting these 3 points on this horizontal line. Okay, after that, after getting these points, just do projectile lines at all these points. These are the vertical projectile lines. Okay, we did this GL line here. Through this line, extend these vertical projectile lines. Okay, after that, here, whatever points we are extending, okay, give the names of intersection points. From O apex, we are extending the line, give the name O1 dash. From A and D, one line is passing here, give A1 dash here. Okay, through A it is passing A1 dash. Through B it is passing give B1 dash. Okay, after getting all these points, join these points to the observer station point. By using scale, join this point to this point and extend the line. Extend this line, O1 line, up to this apex. Okay, apex line. Similarly, join A1 dash to observer, extend this line up A line up to A. A line is coming here. Take the intersection point of A vertical line, A inclined line. Okay. Similarly, join this observer to the B point and extend up to B. So this is the B line, extend up to here. Okay. Here both A and D are coming on the same line. Give A double dash, D double dash. Instead of A dash, B dash, already we are giving the names here. So here we are giving the new names, whatever passing through A and D here. We are giving A double dash, D double dash. Here this is passing through B1 dash. So give the name here B double dash, C double dash. Here apex we are giving O double dash. Okay. Now join all these points by using the scale and pencil. So here we will get the side view of this pyramid. Okay. Like that also, instead of doing the side view in the same diagram, we are doing separately. So this is a method of doing the side view separately. If you are taking some other examples also in this question, so perspective projection and this bigger box is side view. We did this side view separately here. Okay, by taking the reference line, XY line, we did the top view here, front view here, and the side view is, this is the top view, this is the perspective view, this is the side view. Side view we did separate diagram. Okay, by taking the projection lines and transferring these projection points and doing the vertical lines. From here also, doing the projectile lines from all points and joining these points to station point and extending these lines up to the required points. From A vertical line, A inclined line, we will get A double dash like that. Here, after getting all the points, join these points, we will get the side view. In the drawing sheet, we can follow either this method or this method. Both methods are correct. Do only one method in the drawing sheet. If you like this lecture, hit the like button, subscribe my channel and share with your friends. Thank you for watching.